My name is Aleks Damnjanovic, and I'm a principal engineer and manager at Qualcomm. I'm the Spectrum Research Lead in the Wireless Research and Development Department at Qualcomm Technologies. The technologies we develop must be deployable in new spectrum bands. My role is to develop new spectrum access tools to open spectrum bands for new mobile applications. I also ensure these tools are compatible with the regulatory requirements in each country where they will be deployed. At Qualcomm Technologies, our mission is to enable a world where everyone and everything is intelligently connected. So we have teams for research and development, standardization, and engineering. Each of these teams have people dedicated to radio systems and technologies because wireless communications is part of our DNA. The company was named Qualcomm for quality communications, and there can be no wireless communications without spectrum. The mobile ecosystems, I would say, from a high vantage point, consist of devices and the network. On the device side, we have the chipset vendors, and also we have the device vendors. And then on the network side, we have also mobile network vendors, and we have mobile network operators. Qualcomm plays a central role in the device ecosystem, making chips that enable wireless communications between the devices and the network. So while it's hard to think of organizations which do not use radio systems for at least some parts of their operations, we go far beyond using them. We invent technologies for wireless connectivity, and our innovations are used for people like you and me all over the world. Qualcomm has played a foundational role in development of mobile communications technology from the second generation era with code division multiple access, and our subsequent inventions for 3G, 4G, and 5G have connected billions of people and things around the world to the internet. The story with Wi-Fi is similar. Qualcomm innovations have been critical to the success of Wi-Fi 5, 6, and the very latest Wi-Fi 7. We also have a variety of experimental and prototype systems operating with special permissions for research and development, for validating engineering prototypes, and for testing our commercial solutions as part of our customer support activities. So 5G and future 6G mobile communications can wirelessly connect devices across large areas. These networks utilize relatively high power, wide bandwidth, high receiver sensitivity, advanced antenna technology, and rely on planned deployment to provide mobile broadband service in a cost-effective manner. Wi-Fi technology is often used to provide local wireless connectivity on an ad hoc basis, where from an interference management perspective, the least congested channel is used to maximize performance. Some Wi-Fi access points can use spectrum to interconnect and form a mesh. Research and development is a big part of what we do. Our research and development and standardization teams work closely together to make substantial contributions to the standards that enable wireless communications, like those for mobile communications maintained by the 3GPP, or the Wi-Fi standard for radio local area networks, or RLAN, maintained by IEEE. We see constructive engagements with governments and regulatory bodies around the world for the successful commercialization of these standards. As part of spectrum research, we are investigating how mobile and RLAN technologies can be deployed in frequency bands with a wide range of incumbent users. It is very interesting work that involves multiple technologies and new research into how to enable coexistence between them without impacting incumbent users' performance. We are very interested in frequency ranges suitable for the deployment of new RLAN and mobile technologies, such as the 6 GHz band and bands within 7 to 15 GHz range, which is the current focus for 6G deployments. The 6 GHz band is 1200 MHz wide, and while some parts of the world have yet to decide how the upper 700 MHz of that band should be used, Other regions or countries like the US have allocated the entire band to unlicensed use suitable for Wi-Fi. When considering the economic deployment of new 6G mobile technology by the end of this decade, it becomes critical that parts of the 7 to 15 GHz spectrum are made available to mobile services with higher power limits than what unlicensed bands currently support. Radio interference occurs when an unintended transmitter operates close to a receiver engaged in communications with another transmitter. The signal from the unintended transmitter impacts the receiver's ability to receive signal from the intended transmitter. This interference scenario can occur in mobile and in RLAN networks and is managed within the technology. Potential interference across radio systems is managed through regulatory requirements. The next generation of mobile technologies will require more bandwidth than earlier generations, which implies the need for more spectrum. Many of the bands suitable for next generation of mobile technologies already have incumbent users, like federal communication systems and radars, but the spectrum appear to be very lightly used. That presents a great opportunity. If spectrum can be shared across radio systems, many more users can benefit from accessing the spectrum, and spectrum utility would increase. The challenge is getting multiple radio systems to coexist in the same frequency band in a manner that also protects incumbent users. To me, radio spectrum innovation primarily means technology innovation. However, it is also very important that technology innovations accounts for the implications on the regulation and policy. Business aspect of innovative solutions cannot be neglected either. So one aspect is that for mobile technology, in the past and as of now, all the spectrum is exclusively licensed. So that's where we have deployments of mobile networks. However, as we look for new spectrum for 6G, it is becoming clear that finding a lot of spectrum that could be exclusively licensed may be very challenging. So when we talk about technology innovation, we look at ways how to develop new technology that can more easily be deployed in bands where there are incumbents and account for the behavior of these incumbents so that new technology can use these bands. As of now, all the generation of mobile technology assume exclusive licensed spectrum. There is also a mode that allows operation in unlicensed spectrum that follows protocols required for unlicensed spectrum use. But the current systems do not account for potential for sharing spectrum with incumbents that are different type of technologies like radar systems or even satellite systems.